Good afternoon, everyone. Amanda Carter from AMPC here. Just about to start our third part of the series and the final part of the series with energetics as part of the AMPC webinar program that we're currently doing because of COVID and us not being able to get around to all the network meetings in each state. So hope for those that have come along previously, hope that you've enjoyed all the previous webinars. Both Phil and Roger are available if you've got any questions on either of the previous webinars or anything that's indicated today. So this webinar is for Energy and Water Benchmark as part of the Energy and Water Benchmarking series. Roger Horwood and Phil Shorten from Energetics will be presenting the design for the AMPC solar PV and battery plus biomass boiler evaluation tool and service. Matt Deegan from AMPC will present the carbon emissions target and planning. So Matt is the program manager for the sustainability program at AMPC. So if you've got any questions or are interested in doing any PIPs or projects in the sustainability space, Matt is the person to speak to. So today we've gone back to the webinar forum. We really encourage questions. If you have any questions, you will see a questions tab on your toolbar. Please type in those questions and we'll get the relevant presenter to answer your questions throughout the presentation, or if we can't answer them, we'll come back to you at the end. Just as you're leaving, you will have a survey this afternoon. Really appreciate if you can fill out that survey so that we can get feedback to improve the webinars moving forward. So Phil, over to you to start the presentation. Thank you.
Great, thanks Amanda. Good afternoon everyone. Welcome to this webinar. Great that you're online and you're participating. It's good to know there's a few people there. We're not just talking into a void. Yeah, great that you're here. And as Amanda said, we really would welcome your questions today because that'll be much of the back end of the webinar. Our purpose today, look, as Amanda mentioned, we're looking at the development of a tool, a solar PV and battery and biomass boiler tool, and that tool is about comparing the relative business cases for these sorts of options and using a levelised cost of energy approach so that you've got a much better understanding of the total cost of the project and the total benefit of that project, and you can make comparisons in a more meaningful way. But before we get into that tool, there's quite a few things that we want to cover. First of all, we want to look at the carbon emissions targets, and Matt will help us explore that particular aspect. And then Roger's going to take us through some of the background on energy markets. We'll have a look at some of the key elements of assessing solar PV, biomass options. We've got a couple of little case examples to take you through there. And then we'll start to introduce the tool. Now, I just want to stress at this point that the tool is under development. We're not introducing the tool as a complete tool. But what we are seeking at the end of the day is your participation in the development of that tool. And so towards the end, we'll be encouraging questions and looking at ways that you might be able to engage in the development of this tool so that you get a tool that's actually useful, meaningful for you in your investment processes and in your project development processes. So having covered the agenda, what we're going to move on to now is the carbon emissions targets. And Matt, I'd like to just ask you perhaps if you'd like to give us a bit of an overview of the targets in the industry and the connections between AMPC and the MLA in particular with respect to that target. Thanks, Matt.
Thanks, Phil. So as Phil mentioned, one of the motivations for us, for AMPC, engaging Energetics to develop this tool was in a response to carbon emissions. So this tool can not only help make financial savings, obviously, for members, and make those savings more transparent and more evident, but also to help members with their to reduce carbon emissions and measure how they're performing against their the pathway, particularly the industry pathway. So a couple of months ago, we did a report. It was on the emissions reductions pathways and opportunities for red meat processors. And as you can see there in that graph, we looked at 3 pathways for emissions reductions for red meat processors. So those pathways are the orange line, which is under current policy or business as usual. You can see there that the orange line is a fairly gentle slope, reducing emissions from 2005 on to 2030. That's current policy for government policy. And then at 2030, there's a bit of a cliff, a bit of a dramatic drop off because of the identification of that policy after 2030 as to what's going to happen. So it drops off a cliff there because there are other things that our sector has committed to. One of those, more significantly, being the light green pathway, which is carbon neutral 2030. So the red meat industry, that's processors and producers together, have committed to carbon neutral 2030. So you can see there that the light green pathway is a bit more ambitious and inspirational in terms of carbon reduction. And it's targeting carbon neutrality by 2030. In the middle of those 2 pathways is Paris goals, where most of the world is operating on emissions reductions. So the Paris goals is the dark green line pathway, and it's targeting carbon neutrality by 2050. And so when we say carbon neutrality, it doesn't mean that there are no emissions, but it means what little emissions are left over are offset by carbon reduction projects. So looking at the emissions for our sector currently as we stand, that red box there gives those numbers. So we're currently at 432 kilograms of CO2e per tonne of hot standard carcass weight, which has been trending down since 2005. So you can see there in the very dark red line that our sectoral emissions since 2005 have trended down by something in the order of 15%. So there has been some progress made by the sector. What we're looking at in the future, no matter what pathway you look at, is significantly more reduction than what's been achieved in the past. So what's been achieved in the past and continues there under the current policy, the orange line, is basically efficiency improvements, as we all know. The basic step with reductions in energy use, and that's what our benchmarking tool has been helping with members identify. Paris goals then is a bit more ambitious and introduces not just efficiency improvements, but biomass boilers. Biomass boilers are the next cheapest, most effective way to reduce emissions via reduction in Scope 1 emissions. And then the most ambitious pathway with the light green line is carbon neutrality by CN 2030, which is our own industry ambition. And so we need there not just efficiency in biomass, but we'll also need an adoption of a significant amount of solar, and particularly behind the meter, and also wind, most likely through renewable PPAs, etc. Or so that's the rationale for this project, is that if we're going to do more biomass, in boilers, and we're going to do more solar PV with storage, then we'll need a robust tool to compare the business cases so that members feel confident in what they're looking at, because when suppliers or vendors offer those technologies, they can sometimes be opaque, hard to understand. This tool is around introducing transparency through showing on the bottom line the levelised cost of energy, so you can compare between different offers and what your current tariff is. So with that transparency in mind, I'll hand back to you, Phil.
Thanks, Matt. Okay, so that's an excellent backdrop. I think that gives us the context, certainly from an industry perspective. And look, I would appeal to you guys out there that are listening that you know, this is just further evidence of AMPC engaging with industry in a very practical way. I mean, this is, you know, it's not sort of high-level policy or advocacy at this point. It's really about saying, hey, we're going to make some investments in these areas. If we're going to follow some of these pathways, here's a tool that's going to help you with some of those decisions. So again, I just stress that this is an opportunity, starting today with this webinar, to begin popping us some questions, engaging with us in this discussion, and getting involved with the development of the tool so that it's something you can use on site. And I know that for most of you, you know, you've got to beaver away on these business cases, and you've got to, you know, you're in the ear of many people. And so hopefully this tool is going to help you to get your message across, or at least explain what the pros and cons are of various options. Alrighty, okay, so let's move on now to looking at more context now. Okay, so we've looked here at some of the key drivers around emissions for some of these considerable investments. Another area, of course, in terms of business drivers is what's happening with the energy market. And again, just revisiting a couple of key aspects around that market. Some of you will already been exposed to some of this information in previous webinars. But I'd like to hand over now to Roger just to take us through this. And Roger, in particular, with the energy market at the moment, what do you see as being the key drivers for investing in these more strategic opportunities?
Well, at the moment, Phil, I think the momentum to invest in these type of opportunities is dropped a little bit, because we're under COVID-19. We've actually got very low gas and electricity prices, but it actually just shows how volatile the market is. Over the last 10 years or so, the price of electricity and gas have risen very much, and then they've become very volatile. They'll change from day to day, and they're not that predictable. Particularly as we can't predict things like COVID-19, which has changed the whole situation. So reality of it is that we've got a number of things that are happening in the around Australia that are affecting the way in which the price of grid supplied both electricity and gas the price will just continue to fluctuate and change as the time goes on. The investment in renewable solutions gives us an opportunity to reduce some of those costs. And I think another thing is reducing the cost volatility, so you actually can predict where you are a lot more effectively, and at the same time be reducing carbon emissions. I think they're the main drivers. So we might leave it at that for the moment and move on to the assessing of renewable energy projects.
Okay, well, look, in the assessment of those projects then, when we're looking at projects per se, and the ones that we're talking about here are solar and biomass, but there are others, of course, especially in the cogeneration area. This tool that you're developing uses in particular the levelised cost of energy as a part of the data set and as a part of the method of calculating costs and benefits in this business case. Can you just take us through how the levelised cost of energy operates, or how it works?
All right. This is a bit more of the detail being shown on this slide. I won't go through all aspects of this. It's just really there to give you some background. But one of the key areas for levelised cost of energy is that it's a good way of actually comparing one type of energy generation with another. And you can see from the a particular graph that's been shown here for in Australia, the levelised cost or dollars per megawatt for, say, tracking solar PV. It's down $65 to between $35 and $65 per megawatt hour, and you can't buy energy in the market at $35 per megawatt hour at the moment. If it was non-tracking, it's from $39 to $73 per megawatt hour. And then if we move on to, say, pumped hydro, it's as high as $132 up to $569 per megawatt hour. So this graph here gives us an idea of comparing a whole lot of different technologies and the range of costs that we can expect in terms of dollars per megawatt hour. And the idea that we'll have with both the solar PV and battery tool and the biomass boiler tool is we'll create a levelised cost of energy for each of the particular offers you might receive, and you'll be able to compare them and actually say, well, that one's actually giving us a lower levelised cost of energy, so that one may be the better one to go with. But just to give a little bit of background, essentially the overview is that the levelised cost of energy is a summary of all of the costs over a 20-year period or a long period of time, whatever the lifetime of the project is, divided by the energy generation over the same period. And essentially there's various discount factors and investment values that are going into this. The operations and maintenance is being considered. So essentially by having the data available to us for all of these factors, we can determine what the levelised cost of energy is and therefore compare one offer with another. Often the problem is when you get an offer, it actually is based on a lot of maybe different factors or varying types of forecasts, and that can affect the value that you're going to get for the levelised cost of energy. What we're hoping to do with the tool and the service that we're creating here with AMPC is to create something that basically is something you can go to as a reference point that says this is what it should be, and then be able to make business decisions on that. I won't go much further into it at the moment. It shows a lot of the values there, and this presentation is available to you afterwards. Okay.
Okay, Roger, thank you for that. All right, so that's an introduction to some of the mechanics behind the tool, and helps hopefully your confidence in those business case outcomes. We're going to move on to solar PV specifically now and have a look at that area as one of the solution options. The key success criteria for solar PV. Now, there's a lot of things that interact with solar PV. It's not just a sense of, like it is at my place, work out how many panels, what sort of power you need, and away you go. When you're talking commercial and particularly large commercial installations, it starts to get a little bit more complex, a lot more variables, particularly how you interact with the market, etc. So, Roger, can you take us through those key success factors for solar PV? Thanks.
Yes, so we've just listed a number of factors that could influence the feasibility of a solar PV or battery solution. One of the key factors is what are you presently paying for your electricity, and it's often going to be off at around 10 cents to maybe up to 15 cents per kilowatt hour when you can include not only the energy costs for, say, peak and shoulder, which is during the daytime, and the network costs that may be there as well that actually are part of are charged on a basis of kilowatt hours. When you add them up together, you can get into the values even up to 15 cents. But generally, if you've got over 12 cents per kilowatt hour as a variable charge for those peak times and for the addition of the network charges, you'll find that the solar PV starts to become a pretty cost-effective way of going forward, but it relies upon a number of other factors as well. Number two that we've listed here is have a structurally sound roof area that you can mount the solar PV panels, or a very large area or a larger area for mounting the panels on the ground. The picture we've got at the side of this presentation here is the one of the Tees Condamine feedlot where they have a ground mount arrangement. I think it's for about 300 kilowatts worth of electricity or size of system that's there. this was based on the fact that they have the land available to them to be able to do that. For others, it may not be available, and you can only look at the roof space available. Another important factor for assessing solar PV and battery solutions is whether you have a large daytime load. And for most meat processing works, that's the case. You do have large daytime loads, and therefore sizing the solar system to basically meet whatever your daytime load is, or at least meet part of that, is often a good way to go. Another factor that influences the cost of these systems is the capacity available on switchboards. So can you connect your solar PV inverters into your switchboard, and has the switchboard got capacity to do that? And it may not, and that may become an extra cost that you need to look at. And the biggest one that we've found so far, and it's stopped a number of projects in recent times, is whether or not your network area will allow you to export power. We were doing some work in the Riverina area and looking at some dairy farms where they were looking at the idea of installing solar, and found that we couldn't get a feed-in tariff. That's that FIT that I have there. There wasn't a feed-in tariff, or there is a feed-in tariff available, but the reality is the network didn't want to allow us to put export onto the grid because the network area is constrained. It's already reaching its limits in terms of the size of power distribution it's allowed to put through. So it does depend where you're located as to whether or not a solar PV system is a good way to go. And reality is you probably don't want to be exporting very much in most cases at the moment. It's better off if you put a battery with it and store the energy, though that needs to be looked at from a cost-effective point of view. Or you may actually look at the idea of, are there other ways in which you can use that export of the solar PV on your site? It could be in a way that you might actually use it for some load shifting, and so you might actually heat some hot water, for instance, during those periods when you've got excess solar available. It could be for just basically storing some energy in some other form. The other factor that we have to look at when we're looking at whether you want to install batteries is the idea is that whether you're going to use this battery to actually store energy during or store energy from the solar when you've got excess energy, and use it during a peak time so that you get maximum benefit from on the battery storage. And possibly you could use it in what's called demand side response, and that's a process that we're actually doing some studies for at the present moment, where essentially a retailer or a central body would ask your site to actually reduce load for and you could do that by using your battery, for instance, by using the battery to actually reduce load in your plant at that time. So they're the two sorts of areas where you can explore getting some more money for actually installing a battery. Another key factor we found is having an interested retailer, someone that really wants to support you in this and would offer you a feed-in tariff, or even might be interested in doing some DSR work. That's not always the case either, because a lot of the time the areas where there's network constraints, these things become quite a big issue. And finally, we've just noted that a sunny region actually helps improve your payback. You'll notice that the Tees Condamine feedlot, that's in Queensland, where you're getting very good solar kilowatt hour or kilowatts per square metre, say in comparison to either Victoria or Tasmania. But essentially, that's just another factor that we need to take into account. So,
alrighty. Thanks, Roger, for that. So some of the key criteria then for assessing solar and battery solutions. Just have a look at an example of one of the sites that we've recently worked at and how they went about their investment decision. So this particular site was a relatively small site in southern Queensland, and you can see we're really only looking at a little more than 3,000 tonnes per annum, mainly pigs, so pretty small site. This particular site, what they were doing was looking at expansion. So they were looking at increasing. You can see there up to maybe 7,000 tonnes. And the way they were looking at expanding was to actually build a new site, which was only going to be about well, from memory, I think it was something like 700 metres away from their current site, so less than a kilometre. And so a new site, and of course the big benefit there with a new site is that if you get your energy solution in early, you know, you get it's a much better or cheaper to build rather than retrofit often, and of course a better return for the life of the asset. So this particular site also was looking at the challenge around the sizing, and you'll see when you go to look at the case study on the AMPC website, you'll see that there was a lot of different options in terms of the size, number of panels, the you know, the kilowatts that they wanted to produce versus what the business case outcome would be for this particular site. So if you want to look at the detail of all of that, jump on the website, you'll see the fact sheet on this particular site. But one of the other key factors that the owner and manager of the site needed to look at was by going through using the energy benchmarking tool that we introduced in webinar session 1 and looked again at in session 2. Using that tool, the owner was able to better understand what they could do to get more efficient, to get the load down, basically, to get the size of the load down. So they were thinking of excess of 99 kilowatt, but by the time they looked at more efficient equipment, looked at how they would better manage their processes, they were able to bring that load down. They also looked at the renewable energy certificates, and at the time, the small rather than the large renewable energy certificates was more attractive, so they stuck with a less than 100 kilowatt system. And you can see there that that's returned some better profit margins for them. Again, reasonably modest, but over the life of the site, you know, quite considerable for that particular business. Rog, these renewable energy certificates that I just mentioned, can you just give us a little bit more detail, particularly the difference between the small and the large renewable energy certificates?
Okay, Phil, I'll just move it on to the next slide. And I just wanted to touch base on this. It is an important factor in the way we evaluate solar PV systems, and that is there is a renewable energy certificate system that allows you to claim for smaller size systems under 99 kilowatts. You can claim around $40 per megawatt hour, and for large scale systems, the large generation certificates, the value has been as high as 85, almost up to $90 per megawatt hour in early 2018, and then it's dropped away quite rapidly on the basis that we had a certain target that we needed to meet for the renewable energy target, and the fact is we're getting very close to that target, and the amount of installations that are required in both solar in the large scale and in the small scale, we don't need as many as we would. Well, we don't need to have as many, so therefore the price of the certificates has been dropping down. And we can see that the price in the large scale certificates is probably going to go down to about $10 per megawatt hour by about 2022. And this will reduce the payback you get for solar PV systems greater than 99 or 100 kilowatts. Although there's another factor that's influencing the payback for all of these systems, is that the cost of solar PV has been dropping rapidly as well, and it's still continuing to drop down at the moment. And even under COVID-19 situation, where the supplies dried up a little bit because we get a lot of our panels from China, it still means that the price of those panels has still been dropping, and they still will continue to drop into the future. So the overall effect has been that the payback for these projects has actually been improving over time. All right. Okay. The other factor was that,
sorry, Roger.
Yeah, there is another factor regarding the renewable energy target, or the RET. That scheme stops in 2030. So therefore, the claim for your certificates, which used in the smaller systems, you can claim up to 10 years up front. It's not 10 years anymore, because we haven't got 10 years left until we end the scheme. So you actually get shorter and shorter number of years that you're able to claim up front, and that's starting to affect the payback of the projects. And the graph that we've shown here from green energy certificates, or green energy markets actually was the group, they actually show this line here, this dotted one, as the percentage of the cost of the system, or the amount of value of the certificates is actually dropping. You can see it's dropping quite a way, and it's dropping quite rapidly at this stage because you're not claiming as much back each time. So we need to make sure that when you're looking at the evaluation of these systems, that you're evaluating it correctly.
So Roger, how will the tool, just an off-the-cuff question, how will the tool actually factor this in, or is this over and above the usual business case criteria that will be looked at in the tool, the levelised cost?
Oh, no, the tool will include all of this in there in terms, you'll have a forecast of where the pricing will go for both LGCs and for the smaller scale certificates. It'll also include adjust the financial evaluation based on when you're going to install your system, whether it be 2021, 2022, whatever it might be. Yeah. Financials will be adjusted to take that into account.
Excellent. Okay, so again, a good some of this complexity that I mentioned earlier is being built into the tool, reducing the headache for us for investors. Okay, terrific. All right. Look, before we go on to, we're going to start to look at biomass boilers, but before we do, are there any questions at this point about the solar, you know, the argument for solar, or the various dimensions that one needs to look at when investing in solar? Amanda, has any questions come through?
Yes, Phil, there has been a question. So the question is, what sort of battery system is currently being used along with PV at the sites?
The most common system is lithium-ion batteries, but there is others that are gradually coming into the market. The lithium-ion is still relatively expensive to install, but it is the more common one used in the marketplace. I have seen other things that are being used, but they're not that common, so I tend to stay with the lithium-ion.
Okay, thank you for that. All righty. Oh, was there another one, Amanda?
No, sorry, that was the only question so far. So anyone, if you've got any questions, feel free to shoot them through on the question panel, and we'll make sure that we can try and answer them.
Okay, and at the end of the session, we might even try open mic if we can. We'll see how we go.
Regarding the also just was just thinking then, regarding the batteries, we'll actually put in a number of options for the evaluation. So we'll put in different types of battery systems that will be available in the marketplace. We know roughly what they cost, so we can be able to put that variable in there. We can also put in the specifications for those batteries in terms of their charging rates and their discharge rates and the life of those types of batteries.
Okay. All righty. Thank you for that. Keep your questions coming. Thank you, Roger. So we're going to move off from solar PV now and have a look at biomass boilers. And again, we're going to take you through some of the key success factors for investing in biomass and biomass boilers. And then we'll look at some examples and again, hopefully some questions of yours. So the next slide. Thanks Roger. Thank you. So over to you, Roger.
Thanks, mate. Assessing biomass boilers is pretty complex. It can be quite a big investment, and it also can be something that takes a bit of space to install the system, though some of the more modular systems available in the market can allow you to do it in quite a space-effective way. That is a very important element of it, though. Make sure that you do have the space to put a biomass boiler and the fuel handling system that you might use for that. So somewhere to store the wood chips or whatever biomass supply that you're using, and then a transfer system that goes into the boiler itself. The best projects that we've seen in terms of cost effectiveness are ones where they've got an expensive fuel source. That's something like an LPG, for instance, where it can be in the range of $25 to $30, $35 a gigajoule. They're the types of projects that tend to get up fairly quickly. when you have the difference between that 30, well, let's say $25 a gigajoule, and a local biomass supply that might be running at, say, $4 to $7 per gigajoule, that's the driving force to allow us to install a biomass boiler. If you're paying over $10 a gigajoule for natural gas, you can also be in a position where it may be cost effective for you, particularly if you're using a lot of gas. So if you've got one of the larger sites, we've got a figure of 120,000 there gigajoules. It's not necessarily the defining element for putting in a biomass boiler, but big use actually gives you an opportunity to have larger savings. Operating hours is part of that as well. Essentially, if you're operating more often, then essentially that will give you a better return on investment. And generally those systems that are in the low pressure steam area, which is what we state is maybe a little lower than 20 bar, or you might be using just hot water at below, say, 170 degrees, that tends to be a good situation too. That gives you the more cost-effective biomass system. And the other factor that may influence your selection of it is if your existing boiler or one of your existing boilers is about to fail or needs replacement, then that's an ideal opportunity to start thinking about a biomass boiler. And once again, the reason we're thinking of biomass boilers is because we can actually reduce costs, but also we can reduce greenhouse gas emissions as well. And that's on the basis that your fuel source is a carbon neutral or doesn't have a carbon emissions output. So a wood chip that's from a new growth forest, for instance, is certainly that way, but a wood chip from an old growth forest that is not classified as renewable, and therefore you wouldn't be able to claim the carbon emission reductions. So I did have a little bit of a think about the types of fuels that you might be looking at, and we did a study a little while ago, and essentially the types of biomass fuels and costs we were looking at, and you can see they're quite good. The types of fuels we're looking at is one supplier was just waste pellets, so pellets that you usually use for transporting goods around on, that you can get waste ones of those, and they actually use those. You can get just purely waste wood, which is a mixture of different size, different types of woods, and could come from just about anywhere. That one may be not really classified as renewable. You can get sawmill waste, which is generally dust and all sorts of different sized materials, but generally quite small. A bit hard to manage, but can be used in, I know a plant in, I think it's in Bega. I think it's Bega Cheese. They actually have that one that's based on using sawmill dust or waste. There's also, you can use grain dust, which may come from a grain producer or from those that are storing it in silos. There's always a lot of grain dust around. And you can also get different waste wood from board plants where they're processing wood, and you get a wood waste generated from that. And you can see the prices vary quite low. Can be down as $2.50 all the way up into nearly $6 here on supplier number 3. The main factors you've got to look at there is whether or not there's a big enough supply. So the tons per year that you might need for your plant, you need to look at that. And whether or not this is actually a true renewable energy source if you're looking to get carbon reductions. So that's just Roger, a bit of a review of that.
And Roger, what about moisture content, or is that inherent in the calorific value?
Yes,
moisture content's normally a big issue, isn't it?
It is, and in fact, the fact is that this one here, that's I think it's called the sawmill waste, does have a fair bit of moisture within it, and it does. That's what really makes this pricier per gigajoule, is because you need to actually evaporate the water out to get to the point where you're actually burning wood. So a lot of the chips that you might get readily available in the market between $4 and $5 do have a fairly substantial amount of moisture content in them, and therefore you need to take that into account when you're calculating what is the true dollars per gigajoule for that fuel.
Okay. All right. Well, let's look at an example that we worked with recently, and that was on the in the energy benchmarking project. So this was down my way, down the south coast. And this particular abattoir had recently upgraded their site, all nice new boilers, etc. And they were looking for, well, they were building a long-term contract with fish feedstock. So they were using some of the material from their abattoir, but then they were also looking at a new contract that was they were on the verge of signing at the time, and increasing their throughput and ultimately their rendered product. This particular site, though, was very fortunate in that it's located on the Princess Highway down the south coast. And when Roger was looking at the assessment of the various boiler options, and in particular biomass, and looking at the cost effectiveness of biomass, we were sort of teetering, weren't we, Roger? It was kind of a little bit, the numbers weren't looking that flash because of the transport costs of the biomass. And then, of course, we suddenly heard on the grapevine, which was further checked out, that the forest trucks were driving right past the front of the site, and that meant that the transport costs of that biomass were greatly reduced, and the cost of biomass to the site really turned up the attractiveness of the biomass boiler option for these guys. And in particular, with a plant producing somewhere between 600 and 1,000 tonnes of rendered product, they were able to bring their costs down considerably. Fuel cost savings of around $48 a tonne of rendered product, and the payback became very attractive, 2 to 3 years, which is, as many of you are aware, for a strategic project like this, is extremely attractive. And I think the lease option too, Roger, was certainly looked the goods, didn't it? Because it meant that those savings could be immediate.
Yep, basically from day one you're making money.
Yeah,
it was a good arrangement.
All right.
I must admit I don't see too many of those, Phil.
No, it was opportunistic, wasn't it? The fact that
really was, yes.
Yeah, that material was readily available. The trucks just had to drive up the driveway. That was about the cost of transport. And in fact, we know that from a lot of discussions we've had with the industry, with the timber industry, there's more and more biomass material. Now, I haven't checked in since the fires, so I don't know exactly what the current status is. But certainly when we were working with them prior to the fires, they had, well, virtually stockpiles. But again, you'd have to check that out in your local area. But I would definitely, if you're considering this, one of your first phone calls would be to the forest guys and find out where their forest waste is going, and whether or not there's an opportunity there.
Yeah. Okay,
so let's have a look at the tool development at this point, if we could, Rog. Next slide's just looking at, oh, sorry, before we look at the tool, maybe are there any further questions on the biomass opportunity? Amanda, anything come through? Any questions from anyone regarding the biomass business, the business case for biomass boilers?
Yes, Phil, you've got another question from Andrew. Any thoughts being given to solar thermal power plants?
Okay, solar thermal, Roger.
Yes, yeah, certainly solar thermal has been looked at. At this moment, it is fairly expensive. It still hasn't come down in cost, though. There is some very good research and some pilot projects that have been done on solar thermal for both power generation and for thermal generation. So the reality at the moment, though, is it's still not that cost effective for the size of plants that we'd be looking at, say, for red meat processing. I did one probably about a year ago on this, and it was still well over a 10-year payback. So the reality of it is we haven't got to that point where this sort of technology is readily available, particularly at the smaller size levels.
Are there any indications, Roger, that it is something that is being supported in Australia?
Yes.
I mean,
yeah.
again, given the solar aspect.
Yeah, it's been well supported by ARENA. ARENA has invested in a number of different concentrated solar power generation type activities. There's also been the recent development of thermal storage, which is there's a group called 1414, which uses a large salt container, a container of molten salt, which is actually held at 1414 degrees C, and it can be used to store energy from a thermal system, say a biogas system, which is being used for at the SA Water. where they store the energy from the burning the biogas, and then later on they're able to turn that into steam and generate power from it. And that power can be put back onto the grid at the more, I suppose, when they're going to get a better value for it, a better dollar per megawatt hour. That sort of thing is evolving in the market, but it's still not readily available around the market. It's still more in pilot phase.
Thanks, Roger.
But if there was a site that was interested in taking a bit of a dip into the future, and they wanted to look at some sort of trial or pilot of some description, the PIP funding would be probably, Matt, if you're still online, I'm not sure, no, I don't know. But anyway, contact Matt, because he's desperate to get more of that PIP money out into industry. So if you've got an idea, in that, sorry, Matt.
The solar thermal cuts across, well, half a dozen different types of technologies, and as Roger mentioned, some of them are not feasible for red meat producers, and a few, maybe one or two are, but they would be at the lower scale in terms of size. And they're not the traditional concentrated solar thermal technology. They're more your traditional solar thermal type technology. That we would definitely do a PIP for those things. The concentrated solar thermal, as Roger mentioned, the scale I don't think is there yet, so we may not do a PIP for that unless there's a new technology that's proven itself recently somewhere. But always happy to look at solar thermal on the traditional sense of things.
Yep. Good. Yep. Okay. So basically, for hot water and potentially steam, is that?
Yeah, low pressure generation is probably the way you would do it. I looked at other types of solar thermal, very large scale, but they need a lot of area, a lot of land to actually install them. And it has been done around the world, but it hasn't been done that often here.
Right. Okay. All right. Terrific. Well, thanks for that. So I think we move on now to just the current status of the tool and how you were planning to engage with how we are planning to engage with.
There's just a couple of more questions that might be worth talking about right at the moment before you do move on. So the next one is in regards to the conversation you're having around timber. What about chemical treatment of timber? Does that affect using them at all?
Yeah, some types of chemical treatment, you don't really want to be burning it because you don't want arsenic and things getting into the atmosphere. There are things that, there is treatments that they can do to the wood to make sure that they've taken the chemical away from it. And it's a good point. The pellets themselves sometimes can be chemically treated. So the reality is you can only use certain types of wood for the biomass.
Okay, great. And another question is, with the prices of cattle hides dropping to all-time low, what other economic uses, are there any other economic ways of using them for fuel?
I must admit I've never thought of it, but it's a little bit like, would it be fairly dry material? It's a leathery material, isn't it? So it's, so I'm not quite sure.
Yeah, Matt Deegan might have a couple of comments here. I think it's been something you're investigating, Deegs.
The most common response at the moment from members is that with their spare hides that they can't get rid of. They're breaking them down into much smaller, easier parcels to deal with through the rendering stream, which is it's sort of a low value approach to a hide. Obviously a hide has got much more value than that if it's used in the leather area. But with the energy side of things, we haven't come across anything yet, but always looking for something. We've got a couple of projects, 2 or 3 that are looking at value-added products using green hides, and they're underway and they're looking for extra value there. But if someone's got a concept or an idea around how to derive energy from a hide, then we'd be interested. It might be if it's really just sort of accessing the tallow first and then getting energy from the tallow, it sort of defeats the purpose. But if anyone's got other ideas, then you'll be happy to listen, see what those ideas are, and perhaps whether there's something worthwhile testing.
Great, thanks, Matt.
Yes.
And the last question that's currently here is about how about considering cereal straw from our wheat belt region? This is considered as bio-waste resource of low nutritional value, but unsure about the availability in terms of tonnage. Have you had any experience with that?
It's certainly on the list of biomass materials that can be used, and it has been researched before and it has been used before. So there's no reason why it can't be used. It's not as easy to use as a wood chip, for instance, which is more concentrated and heavy duty, but you can use. You may need to use more a gasification type boiler or a fluidized type boiler, which can be a bit more expensive. You may not be able to use it in a standard walking grate type boiler. So reality of it is, yes, it's used and it can be relatively cheap. It's also seasonal. That's the other aspect to it. So getting a consistent supply of it might be more difficult. Perhaps the idea might be to actually use it mixed with other fuels, with other biomass fuels, and particularly you can do that sort of thing with a fluidized boiler where you're actually floating the materials and burning it at the same time.
Mm-hmm.
Excellent, thank you. That's your last question at this point.
Thank you.
Okay, so we might just move on now to the current status of the development of the tool.
I think we've got a lot of information that's been shown on this one slide. Reality of it is what we want to do is for AMPC members who want to assess their offers that they've been received for either a solar PV and battery system or a biomass boiler, is they notify AMPC that they're interested in this, that they provided the proposal and perhaps some energy bills for their various electricity and gas. This would be fed into a tool that would take these types of inputs. You can see a number of different factors we'll take into account. Some of these factors will be built into the tool, and other factors we will need to source either through your proposals or through the marketplace. And then that would be then processed. It goes into an outputs area where it's then put into a report. We'll call it the Levelised Cost of Energy Evaluation Report. And we'll be able to compare a number of different types of offers through this process and provide that report back to the AMPC member. In the event that additional support's required, that can be arranged as well in terms of either technical or financial. That could be looked at. By financial, I mean that you may want to particularly take this process or this particular development through some sort of government funding or perhaps a PIP, as we talked about with Matt. The other thing that will be created out of this process is a database of the solar PV and battery and biomass pricing and the offers that are coming through the market. So there'll be a good database of information to compare things with, and that'll allow this system and basically this service that AMPC will be providing to allow you to make better business decisions about these types of projects. So the main thing that I wanted to get across today is the fact that we would like some assistance, and I just wanted to show this particular schedule that we have in mind for the development of the tool. The initial design has already started. We've now just introduced the tool to you as through this webinar, and that's in June as well. At this point, there's opportunities for you to send information through to AMPC to say, look, we'd like to see this type of evaluation, or these are the factors that we want to consider. Anything that's additional to the sorts of things that we've already spoken about today. Over the next couple of months, we'll develop the draft tool and the service. And what I mean by the service is the process will be that you'll submit things to AMPC. AMPC will run it through the tool and talk to others about how to evaluate that particular project, and then provide a report back to you to help you with your decision making. So once we've got the draft tool and the service together, we'll actually run a members testing. So we'll ask for members that wish to be involved to provide proposals, to provide input to this, and to test the tool and test how the outcomes of that and how well it works for you. And once we have that sort of testing finished, we'll then develop the final tool and the service that AMPC wish to deliver, and that'll be ready in October. So that's the process we want to run through, and we're hoping that members will see this as a valuable tool and a way of helping them to see the value of solar PV and batteries, and also biomass boilers. Bill?
Okay, thanks Roger for that. And I think, so on that note, I'd like to just, before we close, just invite you to ask any more questions. So feel free to turn your mic on and participate in that way if you wish. And before we wrap up, so are there any further questions or comments that anyone would like to offer? Just flick your mic on.
Sorry, Roger. Sorry, Phil. They unfortunately they won't have.
Oh, we haven't got that. Okay. Apologies. I thought I was in webinar 2. This is webinar 3. We don't have that. Okay. Sorry about that, guys. Any more questions? Then please, as you've been doing, just type them down and send them off to Amanda. Amanda, anything else come in?
No, there was only another comment that came in regards to the batteries, and it's more a comment that sodium ion is relatively very cheap. It may be good to consider, and it's environmentally friendly system. So there you go. Thank you for that comment.
Now, there is quite a lot of different battery technologies coming through, and we'll put them into the tool. We just at this stage, I believe lithium ion is just being more common at this stage.
But Roger, that does highlight what you said before. This is the opportunity during this sort of June to September phase, or June to August phase, is for people to influence the scope of this tool, and the things that are going to be considered. I mean, in the final testing, sure, there'll be a little bit of, argy-bargy, but that's fine-tuning. If people want to influence the types of considerations, either the factors that need to be considered or the scope of the technologies, this is the time to put those that information to AMPC so that we can embed that into the tool if it's appropriate. Okay, well, if there's no further questions, then I suppose we'll wrap up at this point. Again, encourage you to participate. Great to see AMPC in a very practical way engaging with industry and providing this kind of service. Roger and I are available afterwards to keep the discussion going, keep the conversation going, and to get that data or information buried or embedded in the tool that we're developing. But as well as that, just help you with whatever project you've got going. We're happy to discuss, email, fee-free from Energetics, only for a little while, to help you along with whatever you're thinking about, whatever projects you're thinking about right at the moment. Okie dokes. So Amanda, back to you to close.
Great, thanks Roger and Phil. It's been a very interesting 3 series webinars from yourselves. Thank you very much, and I do encourage anyone that's interested to get in touch with either Roger or Phil to discuss your individual needs. It is part of the sort of project that we are wrapping up, and also to be involved in Matt's current project around this new tool that is being created. So this concludes the sessions for the Energetics at the present time, and who knows, down the track we might have them back on talking further about the tool and demonstrating the tool, or you might even get to see them in person if we can get back to some meetings on that in the future. So I will just remind everyone there are a number of webinars still coming up, especially in the sustainability space. On the 25th of June, there is one around energy efficiency grants. There's a water grants one on the 28th of August. So just keep checking your emails. We'll make sure that we're sending them through so that you can be actively involved. Thank you everyone for participating. And once again, if you can complete that survey, that helps give us feedback on how we can improve these moving forward. Thank you very much.
Thank you.
Thanks, Amanda. See ya.
Bye.
Bye, everyone.